Hey guys, this is part two of the scientific explanation lecture. So in the first part, we talked about what is scientific explanation, and if we can figure out what that is, how does it go about doing any explaining? Well, suppose we have that figured out, which we don't, but suppose we do. The next relevant question we want to ask is, can science explain everything? Lots of folks think that science can, uh, but look, it can't. I mean, think about ethical questions, for example. Science can't explain to us um, why it's true, say, that rape is wrong. You can't find like the anti-rape particle in under a microscope. Okay, why is it wrong to kill people for no good reason? Why is it wrong to torture children for fun? Right? I mean, those things we know they're wrong. We know it's true that rape is wrong. It's a fact, a moral fact. But of course, science can't explain that fact at all. Okay? So it can't explain ethics. It can't explain moral responsibility. Suppose Jones murders Smith, right? Where Jones and Smith are just made up names. You might ask, why is Jones responsible for having killed Smith? Well, I mean, maybe there are reasons why. Jones shouldn't have done it. Jones had the freedom to do something else, but none of those are explanations that can be gotten in a science lab. You can't look under a microscope, say, and figure out why Jones is morally responsible for having killed Smith. You might be able to explain what caused Jones to kill Smith. You might be able to explain like why Smith died given the actions of Jones. We can't explain why it was, first of all, why it was wrong for Jones to kill Smith for no good reason, and why Jones is responsible, if Jones is responsible, in the moral sense, for her murder of Smith. Science can't explain math. Science can't tell us why 2 plus 2 equals 4. I mean, obviously enough, it can't explain math. It presupposes math. Any scientific explanation is going to presuppose the rules of mathematics. So it doesn't prove or explain the rules of mathematics. It just presupposes that they're there. And the same thing is true about logical reasoning. Science can't prove or explain logic. It depends on logic, so it can't explain it. Okay? So ethics, moral responsibility, math, logic, also conscious experience. Now this is somewhat controversial. But not that controversial. There's the so-called subjective character of experience. There's this really well-known paper by this guy, Thomas Nagel, called What is it like to be a bat? Now, you might be able to imagine, you might think of what it might be like to be a bat, zipping through a cave and dodging through the stalactites and the stalagmites. I can't remember which one's which. But in any case, right, using your radar or whatever to bounce sounds off these things to navigate your way through the dark, you might be able to imagine that. But you can't imagine what it's like for the bat to do that. You can imagine what it'd be like for you to be a bat, but not a bat to be a bat. See the difference? Right? So the problem there, Nagel thought, was, look, if conscious experience was scientifically explainable, it should be objectively accessible, meaning we should be able, in theory, to cut open the bat, dissect it in a particular way where you and I could get the bat's perspective on things. But necessarily you can't, because you'll be viewing the bat's perspective, if that's what you're doing, through your own perspective. You can't get beyond your own subjective experience to get to the bat's experience. And so it seems like, and science is supposed to give us like objective insight into things, how the universe works. But if conscious experience is by definition inaccessible to objective observation, then it's not an explanation that science can't explain it. Science can't explain conscious experience. That's somewhat controversial. I think that seems right. But you can think about that for yourself. In any case, everybody agrees. It can't, basically everybody agrees. It can't explain ethics. It can't explain moral responsibility. It definitely cannot explain math, logic, beauty. It can't explain facts about beauty. Maybe you think that there aren't any facts about beauty. If that's the case, if there aren't any facts about beauty, then any claim like such and such is beautiful is in fact false, because there aren't any beautiful things, aren't any facts about beauty, right? If you think beauty is in the eye of the beholder, it follows that there aren't any beautiful things, because beauty is not in the thing itself, it's in the eye of the beholder. But if you think there are beautiful things, like a beautiful sunset, a beautiful flower, a beautiful person, science can't explain why that thing is beautiful. It might explain like whether or not a particular thing meets the features we find beautiful, like symmetry or something like that, but it can't explain to us why symmetry, say, is beautiful. Okay. All right. In any case, it seems implausible to think that science could explain everything, but suppose it could. All right. Suppose it could. Suppose I'm wrong about all that. It can explain ethics and responsibility, beauty, logic, math, and so on. If it could, we might wonder what branch of the sciences, or is there a branch of the sciences that sort of subsumes all explanation? In other words, is there a branch that sort of whatever explanation you give for a particular thing, it's going to bottom out in that kind of explanation, where that kind of explanation is just a fill-in for some branch of science or other. Maybe physics, for example. Lots of folks think that physics is the most fundamental science, because science is an investigation into the physical realm, the physical world, and physics just is zeroing in on what makes the physical world what it is. Okay, if physics is the study of physical stuff, and science is the study of physical stuff, at least at bottom, then physics is what is the at bottom, i.e., the most basic in the sense of being fundamental science. Okay, and so if science can explain everything, it seems like everything should be explained, given that physics is the most fundamental science. It should be that everything that's explainable should be explainable through physics. But physics can't do that. Physics can't explain everything. So if you read the text, Okashi gives this nice example about an ashtray that raises this problem called the problem of multiple realizability. That's a mouthful. All it means is, look, you can have more than one thing that are ashtrays, and yet, they're physically different, both in color, shape, and so on, right? So the question is, why are these two things ashtrays and not, say, soup bowls? Well, whatever the answer to that question is, there doesn't seem to be a physical explanation. Okay, it has to do more with like purpose, the purpose of the thing. But of course, there's no physical explanation for what the purpose is. Okay, so that's the problem of multiple realizability. You can have these things that come in multiply realizable forms, and yet they're all the same thing, the same kind of thing. They're all ashtrays. Or take automobiles, or glasses, or whatever. Glasses like cups, or glasses like these glasses. Okay. So even if it were true that science, that everything is explainable through the sciences, there doesn't seem to be one particular branch of science that can carry the load of all the explanation. It doesn't seem like whatever explanation you give, even if it can be given scientifically, it's going to bottom out in just one branch. Okay. Now, this is a relevant question to explanation. So if we're seeking scientific explanations about the world, we want to know if what science is giving to us as answers paint an accurate picture of how the world really is. There are two views about this. One is called scientific realism. That's the idea that the sciences try to provide a real, accurate description of how the world is. And then there's scientific anti-realism, or you might call it instrumentalism. The idea there is that science tries to provide a true description of certain parts of the world, namely the parts we can observe, where observable means through our five senses, right? So tables and chairs, stars, planets, animals, and so on. Those are things we can pick up with our five senses, so long as our five senses are working correctly. And so it's not observable things. But they're not trying to give us accurate explanations of the unobservable, which are like the quantum level, for example, atoms, quarks, gluons, and so on. At best, what science is doing at that level, think the anti-realist, is they're giving us kind of useful fictions, hence the name instrumentalism. They're giving us fictitious things like atoms. Do they really exist? No, but they help us predict some things, so they're instrumental in that way. They're useful. That's what instrumental means. They're useful. All right, so instrumentalism is the view that at the realm of the unobservable, what science says is strictly speaking false, but the falsehoods it tells us are they're useful fictions, instrumental. Okay. All right, but realists think that no, everything that the scientists claim about any level, the so-called observable and the so-called unobservable, scientists are trying to get us the real truth. When they talk about how atoms move and what atoms are, that there are atoms and quarks and gluons and so on, the realists think scientists are telling us things that they think are actually true. And of course, anti-realists deny that. They think those theories are just useful fictions, like I said. And the reason why is because we, at least according to them, and we'll see if they're right about this, we can't, allegedly, observe the stuff of particle physics. All right? So anything that we say about the quantum level, since it's unobservable, we can't know whether those claims we're making are true or false, because we can't observe them. Right? We can't, and so we can't know anything at all about the unobservable. That's what they think. All right, so now we have these two camps. Right? We've got the realist who thinks science at every level, the quantum level, you might say, the microscopic level, and then the macro level, you might say, the level of medium-sized dry goods, tables and chairs and dogs and cats. The realist thinks we're trying to paint a true picture at every level, and the anti-realist thinks we're not. So how do we defend realism from the anti-realist's objections? Well, one goes like this. It's called the no miracles argument. Here I've cited John Losey from his historical introduction to the philosophy of science. He says this, quote, this is the argument in a nutshell, the argument from no miracles in a nutshell. Unless one adopts a realist interpretation, the increasing predictive success achieved within the history of science would be a miracle. But of course, we should always prefer the non-miraculous, at least allegedly, we should prefer the non-miraculous explanation over the miraculous one. The miraculous explanation says that these fictitious, the anti-realist says, look, there aren't everything we say at the quantum level is false, but hey, just by happy accident, all has these falsehoods actually are super predictively successful, and isn't that nice? And the realist comes along and says, no, dude, that's a miracle. If our falsehoods are that wildly predictively successful. And so they go, it can't be a miracle. We should favor the non-miraculous view and just say, look, that means not that we just got lucky guesses somehow. No, we're actually saying something true about the micro level. Okay, so we should conclude, say the realist, that the realist interpretation of science is the way to go. Now, of course, one problem with that no miracles argument is this. There have been lots of scientific advancements that have been made. So advancements made because of false theories. And so advancement is no indication of truth. That's what the anti-realist says. Now, we could try to modify what the realist says, the no miracles argument, and say, look, empirical success of a theory is evidence that the theory is at least approximately true. Right? So we have all these theories about quarks and gluons and atoms, and maybe we're not spot on, say the realist, but it's close. It's got to be close, or else there's no good way to explain the predictive success our theories have, except for unless you cite a miracle, but we shouldn't cite miracles. So let's suppose, the reasonable thing to suppose is that our explanations are at least close to right. But of course, this has problems too. If you think of Auguste Fresnel, he thought that light consists of vibrations in the ether. There is no such thing as ether, okay? There's no such thing as light vibrations in the ether. His theory, not even close to being right. Right? But it was wildly successful in its predictions. So here we have a case, and there's more like that besides. Here we have a case, though, of something that was not even close to true, that was successful in its predictions. I mean, very successful in its predictions. Okay, so if science is replete with examples like this, that's fodder for or ammunition in the weapon of the anti-realist response to the no miracles argument on behalf of the realist. All right, now another response, if you don't like the no miracles argument for the realist, is this. We can ask the anti-realist, what counts as observable? All right, so just think about this list. Does it count as observable if I see something with the naked eye? That seems pretty plainly, obviously so. What about if I have to put on glasses? Is that still observable? I mean, I, in theory, wouldn't have seen it without my glasses, or at least not seen it well. What about seeing something through a telescope? There's lots of stuff I wouldn't be able to see without the aid of a telescope. So are those things observable or unobservable? What about a microscope? Same deal. What about a cloud chamber? Cloud chambers, you don't strictly speaking see the electron, but you see evidence of the electron having moved. Okay. Is that an observation of, is that a type of observation of an electron? So the objection goes, there isn't any principled way to draw a hard line between what counts as observable, and so according to the anti-realist, real, and unobservable, and so according to the anti-realist, not real. There's no way to draw that line, say the realists. Okay. All right, so those are two potential ways to respond to the anti-realist claim that science can't actually give us, isn't even trying to give us truth at the unobservable or quantum level. Now, is there anything we can say in defense of anti-realism? Sure, there's the so-called underdetermination argument. So realists claim that observational data, whatever observational data you have, that's what constitutes the ultimate evidence for something, for unobservable entities. So think, for example, about that cloud chamber. We have all this observable data, like, for example, the lines moved in the vaporized water particles inside the cloud chamber. That seems to be observable evidence for the movement of electrons. Okay, so even if we grant that electrons are unobservable, we have evidence that we have observable evidence that those things exist and are real. Okay, but the anti-realist says this to such a claim. That's fine. Let's agree that we have observable data that you can use to suggest that there are things like electrons and quarks and gluons and so on. The problem is those data, you're having seen the lines caused in the water vapor in the cloud chamber, those underdetermine the theories that they're meant to support. And what that means is essentially this: for any set of data you can think of, there's an infinite number of theories to explain the data, right? I mean, okay, let's agree that we can all see lines caused, that there are lines that have been caused inside the water vapor particles of the cloud chamber. Why does it follow from that that's the movement of an electron? Well, it doesn't, right? I mean, it could be a little green man from Mars in there. I mean, nobody would think that, but the point is that theory, that data would just as easily explain the theory about the little green man from Mars as it does an electron, right? But that's going to be the case with every bit of data you can think of, every set of data you can think of. They always underdetermine the theory that they're alleged to support. And so the question is, what reason is there to favor the particular theory you gave, that's an electron that caused those, as opposed to something else? Right? And according to the anti-realist, there doesn't seem to be any good reason to favor your hypothesis over, say, mine about the Martian or whatever. Okay. Now, so that's an objection from the anti-realist to, or that's an argument in favor of anti-realism. So now let's think if there's a realist response to the argument for anti-realism, right? Well, the realist is going to pull out Occam's razor. So William of Occam, if you're familiar with Occam's razor, he basically just said the simplest explanation is probably the right one. So take some bit of phenomena, something that happens. If I can fully well explain it with some particular hypothesis, and you come along and you go, yeah, I get your hypothesis, but I'm going to add to it, oh, aliens also. The original hypothesis doesn't include aliens. Yours is like the original hypothesis, but it includes aliens. Occam's going to say, pick the one without the aliens, because if they're the same, that adding the aliens bit, it doesn't do anything. It's absolutely useless with respect to what's doing the explaining. Okay, so the razor says cut off the extra stuff that you don't need. All right, pick the theory that has the fewest add-ons, you might say. Right, the simplest theory is the best, according to Occam. All right, so we can cite Occam's razor for realists. We can also cite inference to the best explanation, or IBE, or inductive inference, if you like to call it that, too, from the text and also from the logic slides. Okay, and this is just standard scientific practice, is inference to the best explanation. That's what scientists are always doing. It's just a trivial truth about science that for any set of data you have, there's an infinite number of hypotheses that equally well explain the data. Okay, what you have to do is make an inference to the best explanation. So what's a more plausible explanation for the lines caused in the water vapor particles in the cloud chamber? Is it the movement of this electron that we've hypothesized is there and done a bunch of experiments to see whether or not it's there? Or is it a little green man from Mars? Well, everybody should agree it's definitely not a little green man from Mars. Why? Because that's super implausible. We know there aren't any little green men from Mars. So we can rule that out. Okay. Now we can just keep testing other hypotheses in contradistinction to the hypothesis about the electron. But in any case, the point is to make an inference to the best explanation. And if the electron movement is the best explanation, that's the one we should pick. Okay. So even if that argument from underdetermination is successful, even if they were to run this argument from underdetermination, we should see that that's not really a problem for science just as such, because if the argument from underdetermination is successful against science, it's successful against basically every other kind of knowledge that comes from observation. Right? I mean, you think that you are watching a lecture right now on a PowerPoint slide on your computer. So that's a bit of data. Well, one hypothesis to explain that data is that you are in fact watching a video lecture on some slides in this course that you're taking online through Tennessee eCampus on your computer and so on. Well, here's a competing hypothesis. You're stuck in the Matrix. You guys know what the Matrix is? It's a movie, 1999. If you haven't seen it, you should watch it. It's excellent. And it's a nice philosophical thought experiment. The Matrix the idea is human beings, what we experience in the world is really just a simulation input into our brains from a machine world that exists outside. And really, we don't know it, but our actual bodies are asleep in vats of chemicals. And what we experience as everyday real life is just an imagination, an image put into our brains from the machines. Well, that's perfectly possible. And that would explain the exact same thing you're experiencing right now, that you're watching this video lecture on this slideshow and you're looking at a computer and so on. Those hypotheses equally well explain the data. Right? If this underdetermination argument is right, given that both of those hypotheses equally well explain the data, you can't know that you're not stuck in the Matrix. But of course you can. You know you're not stuck in the Matrix. Now, can you be sure that you're not stuck in the Matrix? No. That's just what it means for the data to underdetermine. Okay? But it doesn't follow from that you don't know. Scientific knowledge just as such can't require certainty. If it does, we should be radical skeptics like David Hume and claim that we can't know anything. But that seems absurd. You do know stuff. You know you're watching this. You know what your name is. You know where you live, and so on, even though you can't guarantee any of that. And that's fine. Okay. So if the underdetermination argument goes through, it's not just a problem for science. The point is it's a problem for knowledge just as such. All right? And that's because it's just a restatement of Hume's problem of induction. Most of our knowledge is gotten through inductive inference. Okay? Knowledge about the world. If Hume's right, we can't know anything about the world. But I'm pretty sure Hume's wrong. I mean, you can think about this yourself. You might agree with Hume that we can't, in fact, know anything about the world. We can't, in fact, know that we're not stuck in the matrix. And so the argument from underdetermination really will undermine realism about science, because it's not just the unobservable we can't know about. If you want the underdetermination argument to work, it's going to follow that we can't know anything even about the observable realm. Science can't, it's not just anti-realism about the unobservable, it's anti-realism about anything. And maybe that's right, but you'll have to think about that for yourself. Okay, that's the end of part 2 of this lecture. We'll see you next time.